Chapter 10, Part 2 of The Origin of Species by Means of Natural Selection by Charles Darwin. This recording is in the public domain. On the sudden appearance of whole groups of allied species. The abrupt manner in which whole groups of species suddenly appear in certain formations has been urged by several paleontologists, for instance, by Agassiz, Pictet, and Sedgwick, as a fatal objection to the belief in the transmutation of species. If numerous species belonging to the same genera or families have really started into life at once, the fact would be fatal to the theory of evolution through natural selection, for the development by this means of a group of forms, all of which are descended from some one progenitor, must have been an extremely slow process, and the progenitors must have lived long before their modified descendants. But we continually overrate the perfection of the geological record, and falsely infer, because certain genera or families have not been found beneath a certain stage, that they did not exist before that stage. In all cases, positive paleontological evidence may be implicitly trusted. Negative evidence is worthless, as experience has so often shown. We continually forget how large the world is, compared with the area over which our geological formations have been carefully examined. We forget that groups of species may elsewhere have long existed, and have slowly multiplied before they invaded the ancient archipelagos of Europe and the United States. We do not make due allowance for the enormous intervals of time which have elapsed between our consecutive formations, longer, perhaps, in many cases, than the time required for the accumulation of each formation. These intervals will have given time for the multiplication of species from some one parent form, and in the succeeding formation, such groups or species will appear as if suddenly created. I may here recall a remark formerly made, namely, that it might require a long succession of ages to adapt an organism to some new and peculiar line of life, for instance, to fly through the air, and consequently that the transitional forms would often long remain confined to some one region, but that, when this adaptation had once been effected, and a few species had thus acquired a great advantage over other organisms, a comparatively short time would be necessary to produce many divergent forms which would spread rapidly and widely throughout the world. Professor Pictet, in his excellent review of this work, in commenting on early transitional forms, and taking birds as an illustration, cannot see how the successive modifications of the anterior limbs of a supposed prototype could possibly have been of any advantage. But look at the penguins of the Southern Ocean. Have not these birds their front limbs in this precise intermediate state of, quote, neither true arms nor true wings, end quote? Yet these birds hold their place victoriously in the battle for life, for they exist in infinite numbers and of many kinds. I do not suppose that we here see the real transitional grades through which the wings of birds have passed. But what special difficulty is there in believing that it might profit the modified descendants of the penguin, first to become enabled to flap along the surface of the sea, like the locker-headed duck, and ultimately to rise from its surface and glide through the air? I will now give a few examples to illustrate the foregoing remarks, and to show how liable we are to error in supposing that whole groups of species have suddenly been produced, even in so short an interval as that between the first and second editions of Pictet's great work on paleontology, published in 1844-46, and in 1853-57. The conclusions on the first appearance and disappearance of several groups of animals have been considerably modified, and a third edition would require still further changes. I may recall the well-known fact that in geological treatises published not many years ago, Mammals were always spoken of as having abruptly come in at the commencement of the Tertiary series, and now one of the richest known accumulations of fossil mammals belongs to the middle of the Secondary series, and true mammals have been discovered in the new red sandstone at nearly the commencement of this great series. Cuvier used to urge that no monkey occurred in any tertiary stratum, but now extinct species have been discovered in India, South America, and in Europe, as far back as the Miocene stage. Had it not been for the rare accident of the preservation of footsteps in the new red sandstone of the United States, who would have ventured to suppose that no less than at least 30 different bird-like animals, some of gigantic size, existed during that period? Not a fragment of bone has been discovered in these beds. Not long ago, paleontologists maintained that the whole class of birds came suddenly into existence during the Eocene period. But now we know, on the authority of Professor Owen, that a bird certainly lived during the deposition of the upper green sand, and still more recently, that strange bird, the Archaeopteryx, with its long lizard-like tail, bearing a pair of feathers on each joint, and with its wings furnished with 2 free claws, has been discovered in the oolitic states of Solnhofen. Hardly any recent discovery shows more forcibly than this how little we as yet know of the former inhabitants of the world. I may give another instance which, from having been passed under my own eyes, has much struck me. In a memoir on fossil sessile cirripedes, I stated that, from the large number of existing and extinct tertiary species, from the extraordinary abundance of the individuals in many species all over the world, from the Arctic regions to the equator, inhabiting various zones of depths, from the upper tidal limits to 50 fathoms, from the perfect manner in which specimens are preserved in the oldest tertiary beds, from the ease with which even a fragment of a valve can be recognized, from all these circumstances I inferred that, had sessile cirripedes existed during the secondary periods, they would have certainly have been preserved and discovered, and as not one species had then been discovered in beds of this age, I concluded that this great group had been suddenly developed at the commencement of the tertiary series. This was a sore trouble to me, adding, as then I thought, one more instance of the abrupt appearance of a great group of species. But my work had hardly been published when a skilful paleontologist, M. Bosquet, sent me a drawing of a perfect specimen of an unmistakable sessile cirripede, which he had himself extracted from the chalk of Belgium. And as if to make the case as striking as possible, this cirripede was a Thamylus, a very common, large, and ubiquitous genus, of which not one species has as yet been found, even in any tertiary stratum. Still more recently, a Pergoma, a member of a distinct subfamily of sessile cirripedes, has been discovered by Mr. Woodward in the upper chalk, so that we now have abundant evidence of the existence of this group of animals during the secondary period. The case most frequently insisted on by paleontologists of the apparently sudden appearance of a whole group of species is that of the teleostean fishes, low down, according to Agassiz, in the chalk period. This group includes the large majority of existing species, but certain Jurassic and Triassic forms are now commonly admitted to be teleostean, and even some Paleozoic forms have thus been classed by one high authority. If the teleosteans had really appeared suddenly in the northern hemisphere at the commencement of the chalk formation, the fact would have been highly remarkable, but it would not have formed an insuperable difficulty, unless it could likewise have been shown that at the same period the species were suddenly and simultaneously developed in other quarters of the world. It is almost superfluous to remark that hardly any fossil fish are known from south of the equator, and by running through Pictet's paleontology, it will be seen that very few species are known from several formations in Europe. Some few families of fish now have a confined range. The teleostine fishes might formerly have had a similarly confined range, and after having been largely developed in some one sea, have spread widely. Nor have we any right to suppose that the seas of the world have always been so freely open from south to north as they are at present. Even at this day, if the Malay archipelago were converted into land, the tropical parts of the Indian Ocean would form a large and perfectly enclosed basin, in which any great group of marine animals might be multiplied, and here they would remain confined until some of the species became adapted to a cooler climate and were enabled to double at the southern capes of Africa or Australia, and thus reach other and distant seas. From these considerations, from our ignorance of the geology of other countries beyond the confines of Europe and the United States, and from the revolution in our paleontological knowledge effected by the discoveries of the last dozen years, it seems to me to be about as rash to dogmatize on the succession of organic forms throughout the world as it would be for a naturalist to land for 5 minutes on a barren point in Australia, and then to discuss the number and range of its productions. On the sudden appearance of groups of allied species in the lowest known fossiliferous strata. There is another and allied difficulty which is more serious. I allude to the manner in which species belonging to several of the main divisions of the animal kingdom suddenly appear in the lowest known fossiliferous rocks. Most of the arguments which have convinced me that all the existing species of the same group are descended from a single progenitor apply, with equal force, to the earliest known species. For instance, it cannot be doubted that all the Cambrian and Silurian trilobites are descended from some one crustacean, which must have lived long before the Cambrian age, and which probably differed greatly from any known animal. Some of the most ancient animals, as the nautilus, lingula, etc., do not differ much from living species, and it cannot, on our theory, be supposed that these old species were the progenitors of all the species belonging to the same groups which have subsequently appeared, for they are not in any degree intermediate in character. Consequently, if the theory be true, it is indisputable that before the lowest Cambrian stratum was deposited long periods elapsed, as long as, or probably far longer than, the whole interval from the Cambrian age to the present day, and that during these vast periods the world swarmed with living creatures. Here we encounter a formidable objection, for it seems doubtful whether the earth, in a fit state for the habitation of living creatures, has lasted long enough. Sir W. Thomson concludes that the consolidation of the crust can hardly have occurred less than 20 or more than 400 million years ago, but probably not less than 98 or more than 200 million years. These very wide limits show how doubtful the data are, and other elements may have hereafter to be introduced into the problem. Mr. Kroll estimates that about 60 million years have elapsed since the Cambrian period, but this, judging from the small amount of organic change since the commencement of the glacial epoch, appears a very short time for the many and great mutations of life which have certainly occurred since the Cambrian formation, and the previous 140 million years can hardly be considered as sufficient for the development of the varied forms of life which already existed during the Cambrian period. It is, however, probable, as Sir William Thomson insists, that the world, at a very early period, was subjected to more rapid and violent changes in its physical conditions than those now occurring, and such changes would have tended to induce changes at a corresponding rate in the organisms which then existed. To the question why we do not find rich fossiliferous deposits belonging to these assumed earliest periods prior to the Cambrian system, I can give no satisfactory answer. Several eminent geologists, with Sir R. Murchison at their head, were until recently convinced that we beheld, in the organic remains of the lowest Silurian stratum, the first dawn of life. Other highly competent judges, as Lyell and E. Forbes, have disputed this conclusion. We should not forget that only a small portion of the world is known with accuracy. Not very long ago, M. Barrand added another and lower stage, abounding with new and peculiar species, beneath the then known Silurian system, and now, still lower down in the lower Cambrian formation, Mr. Hicks has found South Wales beds, rich in trilobites, and containing various mollusks and annelids. The presence of phosphatic nodules and bituminous matter, even in some of the lowest azotic rocks, probably indicates life at these periods, and the existence of the Eozoon in the Laurentian formation of Canada is generally admitted. There are 3 great series of strata beneath the Silurian system in Canada, in the lowest of which the Eozoon is found. Sir W. Logan states that their, quote, united thickness may possibly far surpass that of all the succeeding rocks, from the base of the Paleozoic series to the present time. We are thus carried back to a period so remote that the appearance of the so-called primordial fauna of Barrand may by some be considered as a comparatively modern event." The Eozoon belongs to the most lowly organized of all classes of animals, but is highly organized for its class. It existed in countless numbers, and, as Dr. Dawson has remarked, certainly preyed on other minute organic beings which must have lived in great numbers. Thus the words which I wrote in 1859 about the existence of living beings long before the Cambrian period, and which are almost the same with those since used by Sir W. Logan, have been proved true. Nevertheless, the difficulty of assigning any good reason for the absence of vast piles of strata rich in fossils beneath the Cambrian system is very great. It does not seem probable that the most ancient beds have been quite worn away by denudation, or that their fossils have been wholly obliterated by metamorphic action, for if this had been the case, we should have found only small remnants of the formations next succeeding them in age, and these would always have existed in a partially metamorphosed condition. But the descriptions which we possess of the Silurian deposits over immense territories in Russia and in North America do not support the view that the older a formation is, the more invariably it has suffered extreme denudation and metamorphism. The case at present must remain inexplicable, and may be truly urged as a valid argument against the views here entertained. To show that it may hereafter receive some explanation, I will give the following hypothesis. From the nature of the organic remains, which do not appear to have inhabited profound depths in the several formations of Europe and of the United States, and from the amount of sediment, miles in thickness, of which the formations are composed, we may infer that from first to last large islands, or tracts of land, whence the sediment was derived, occurred in the neighborhood of the now existing continents of Europe and North America. This same view has since been maintained by Agassiz and others, but we do not know what the state of things in the intervals between the successive formations, whether Europe and the United States during these intervals existed as dry land, or as a submarine surface near land on which sediment was not deposited, or as the bed of an open and unfathomable sea. Looking to the existing oceans, which are thrice as extensive as the land, we see them studded with many islands, but hardly one truly oceanic island, with the exception of New Zealand, if this can be called a truly oceanic island, is as yet known to afford even a remnant of any Paleozoic or secondary formation. Hence, we may perhaps infer that during the Paleozoic and secondary periods, neither continents nor continental islands existed where our oceans now extend. Hence, we may perhaps infer that during the Paleozoic and secondary periods, neither continents nor continental islands existed where our oceans now extend, for had they existed, Paleozoic and secondary formations would, in all probability, have been accumulated from sediment derived from their wear and tear, and would have been at least partially upheaved by the oscillations of level, which must have intervened during these enormously long periods. If, then, we may infer anything from these facts, we may infer that, where our oceans now extend, oceans have extended from the remotest period of which we have any record, and, on the other hand, that where continents now exist, large tracts of land have existed, subjected, no doubt, to great oscillations of level since the Cambrian period. The colored map appended to my volume on coral reefs led me to conclude that the great oceans are still mainly areas of subsidence, the great archipelagos still areas of oscillations of level, and the continents areas of elevation. But we have no reason to assume that things have thus remained from the beginning of the world. Our continents seem to have been formed by a preponderance, during many oscillations of level, of the force of elevation. But may not the areas of preponderant movement have changed in the lapse of ages? At a period long antecedent to the Cambrian epoch, continents may have existed where oceans are now spread out, and clear and open oceans may have existed where our continents now stand. Nor should we be justified in assuming that if, for instance, the bed of the Pacific Ocean were now converted into a continent, we should there find sedimentary formations in recognizable condition, older than the Cambrian strata, supposing such to have been formerly deposited, for it might well happen that strata which had subsided some miles nearer to the centre of the earth, and which had been pressed on by an enormous weight of superincumbent water, might have undergone far more metamorphic action than strata which have always remained nearer to the surface. The immense areas in some parts of the world, for instance, in South America, of naked metamorphic rocks, which must have been heated under great pressure, have always seemed to me to require some special explanation, and we may perhaps believe that we see in these large areas the many formations long anterior to the Cambrian epoch in a completely metamorphosed and denuded condition. The several difficulties here discussed, namely that though we find in our geological formations many links between the species which now exist and which formerly existed, we do not find infinitely numerous fine transitional forms closely joining them all together. The sudden manner in which several groups of species first appear in our European formations, the almost entire absence, as at present known, of formations rich in fossils beneath the Cambrian strata, are all, undoubtedly, of the most serious nature. We see this in the fact that the most eminent paleontologists, namely Cuvier, Agassiz, Berrand, Pictet, Falconer, E. Forbes, etc., and all our greatest geologists, as Lyell, Murchison, Sedgwick, etc., have unanimously, often vehemently, maintained the immutability of species. But Sir Charles Lyell now gives the support of his high authority to the opposite side, and most geologists and paleontologists are much shaken in their former belief. Those who believe that the geological record is in any degree perfect will undoubtedly at once reject my theory. For my part, following out Lyell's metaphor, I look at the geological record as a history of the world imperfectly kept and written in a changing dialect. Of this history we possess the last volume alone, relating only to 2 or 3 countries. Of this volume, only here and there a short chapter has been preserved, and of each page only here and there a few lines. Each word of the slowly changing language, more or less different in the successive chapters, may represent the forms of life which are entombed in our consecutive formations, and which falsely appear to have been abruptly introduced. On this view, the difficulties above discussed are greatly diminished, or even disappear. End of chapter 10, part 2.